Hello, I'm Pete Starkey at Real Time with IPC here at the IPC Apex Expo in San Diego. It's the second day of what appears to be an extremely busy show. I'm delighted to have the opportunity to sit down for a few minutes with Richard DePoto, who is with Oyamura. Richard, it's great to meet you, and thank you very much indeed for joining us.
It's a pleasure to be here, Peter.
Thank you. Richard, we recognise Oyamura as a very long-established supplier to the metal finishing and the electronics and printed circuit board industry, and also a company that's got a very heavy focus on research and development. I understand that you've done a lot of work on a new gold process that's not necessarily an electroless gold or not necessarily an immersion gold, but something somewhere in between. Could you tell us about this process and really what needs it satisfies, what it will do for the industry?
Sure. Yeah, it's a product that we've been working on for a while. It's been introduced now in the market, at least in the U.S., for the past year. The difference that this product is that the standard ENIG and even NPIG processes use an immersion gold process. And what we've created is a reduction assisted one. So it's a hybrid between the immersion gold process and the electroless. And the advantages are that you can achieve the thicknesses of gold that everybody really wanted to specify. Upwards of 5 microinches all the way up to 8 microinches, which are unachievable with immersion. And you can do it in a very stable bath environment. And so the guidelines of the new IPC spec 4552 have taken particular close attention to that corrosion reaction that occurs in attempting to minimize it. And this product takes that and addresses that at a very important and new level.
There's a lot of work been done really over and over again to get closer to explaining what causes black pad effect, hypercorrosion effects on electroless nickel during the traditional immersion gold deposition reaction. And I think that the knowledge and understanding of that has improved. It's not as mysterious as it was, but it still couldn't be a problem with the conventional processes.
That's true. Pete, if you talk to process engineers, most of them will tell you that the most difficult process to run in their facility is that electroless nickel gold reaction. Its process window, unlike the electrolytic part of the side, is so much more difficult, and the process window is small. So we have strived really hard to make that processing window as wide as possible. And give a lot more flexibility to the process.
You can operate this process as a sort of replenishable steady state system, or is it a make up, use and remake?
Absolutely, replenishment system. There's always cost is a large issue. Even though at that part of the process the boards are pretty expensive. With the cost of gold, it has to be a replenished system. So this is this is a replenishable bath.
What sort of process conditions, what sort of times and temperatures are involved?
What's nice about it is that the process times are equal to what is used now in your immersion bath reaction. So on the order of anywhere, depending on the thickness that you want, anywhere from 10 to 30 minutes at a reasonable temperature. And so it's really a drop-in process. Now some people may elect to put it in as a separate bath and only dedicate that specialty work that requires the high spec for that. But you could run it either way. We think that this will be the future of how ENIG processes will run. We think this is what the industry was looking for from the beginning.
I think if I'm honest, right from the beginning the industry didn't really know what it was looking for. The industry, I think, started off looking for a flat finish for surface mount applications, and it was at a time when standard finish was hot air solder level tin lead.
Absolutely.
And I think the electroless nickel immersion gold looked pretty. Yeah. And quite honestly, as a long-standing PCB fabricator, I think an awful lot of people specified electroless nickel immersion gold for no other reason than they liked the look of it. They didn't really know what they wanted, provided that it didn't interfere with their paste printing and component placing operations.
Absolutely. The flatness that was a big win when surface mount technologies were just sort of growing, so that was the key. Of course, with the gold, it had good shelf life as well. Yeah. So it handled travel and shipment, and gold is highly solderable. Yes. The coatings are relatively thin, so it didn't have the gold embrittlement. So it really found a great place for a long time. Yeah.
What are typical deposit thicknesses that this new process is? Well, you've said, because it's not a sort of self-limiting immersion process, you can effectively high build it, but what sort of thicknesses are people calling for?
So the standard IPC specification, the 4552 Rev A, has brought the thicknesses actually lower, somewhere between 1 microinch and 4 microinches. But there are still many specs out there, even on the military side, that call for thicknesses greater than that. This particular process can produce anything from 1 up to 8 microinches in thickness.
But you're in control of that, and I think that's a big difference compared with the immersion process.
And what came out of it that surprised us is that the uniformity of the deposit. As you know, electroless processes are known for their uniformity of thickness. So when you get to those thicknesses, really every pad geometry will have the same thickness. So the process, in many ways, can be even less expensive than trying to get any thickness out of an immersion, because in some cases you're overplating. So, so we're excited about that.
I know exactly what you're talking about. Do you have any sort of typical recent case history of where a customer's come to you with a particular challenge that you've been able to respond to?
Yes, we have. And specific to this product, which is our featured product, is that OEMs operating in harsh environments overall have been fairly disappointed, I'll say, with ENIG and the NPIG processes. It's not that they have a number of failures, but they see inconsistencies. Yeah. And in those harsh environments where we've gone to pogo pin insertion and hydrostatic pressure holding down components, the underlying barrier layers, it's critical that they are ion free and free of corrosion, and that there is no porosity in the deposit. And so when we submitted samples with the higher thickness and the lower porosity gold, the performance of those components was dramatically improved, and the consistency of the process.
That's great. No, so it's a really interesting conversation, which I could probably bore you with for a long time. So far, the focus has been on putting a layer down on top of nickel. Correct. But the high frequency boys don't necessarily like that nickel there for what it's going to do to their signal integrity. So what are the alternatives?
Okay, and we're very excited how fast this has moved. We've gotten actually more requests frequently than we even expected, because we didn't know if the nickel was going to be that serious on high frequency on component pads. But people are looking to eliminate all variation, and so they've come to us and said, look, can we eliminate the nickel? And so we have developed a process where we're able to plate palladium directly on the copper, eliminating the nickel, and then put that the reduction assisted gold directly on top of the on the palladium. So that's an E-pig.
Yeah, E-pig. Yeah, we've got a whole generation of pigs now, haven't we?
And so,
what sort of deposit thickness of electroless palladium are you talking about?
It depends on the application. But it can be anywhere from about 8 up to about 15 or 16. microinches
Yeah.
of palladium, depend on the sealing properties that you're looking for.
Yeah. And similar sort of process times and temperatures with nickel, or very different?
No, the process times are about the same.
Yeah.
The electroless palladium processes are a little trickier to run than the electroless nickel because of the catalytic nature of the palladium.
Yeah.
But we have made a lot of progress on the electroless palladium side in the past couple of years. We actually have a platform of palladium baths. Currently we have actually 5 that are available, depending on your application, the volume that you run through, and the laminates have a big role to play. All of the new laminates that are out there dramatically affect the performance of all of these plated deposits. There's leachables, and we constantly hear different laminates performing different in ENIG. And so that has been one of the challenges, and we feel like we've gotten the stability to the point where we can match things up pretty well right now.
That sounds pretty good. Richard, it's been really interesting to talk with you, and thank you for sharing all of this knowledge with us.
That sounds great. It's been a pleasure.
You say it's an active show, and there's a lot of interest in these new processes.
Yeah, we've been very happy with the show this year, and we've had great discussions.
Thanks very much indeed for joining us.
Thank you so much.
Really appreciate it.
Thank you.
Pete Starkey, Real Time with IPC. Thank you.